Hi everyone, I'm Chen Yi. Today I'm going to talk about the hidden influence of large particles on ocean color, almost very different. And to our introduction, here is two ends that we want to know. First is do large marine particles influence optical properties? And the second is why do we mix large particles with optical sensors? The word optical means it's relating to light. So we all know the ocean color generally is blue. So we want to know why the color is blue. And the oceanic particles influence the way that the light proceeds, such as the scattering, reflection, and absorption. And we know that clear water will generally present lower particle concentrations than productive coastal waters. So here is an example. This is the red tide, and it's an example of the particle influence the ocean color. So this picture, the y-axis is the concentration of particle, and the x-axis is the size. So you can see when the species like bacteria and phytoplankton, when you have a large amount of the number in the environment, you have the high concentration. And when your size gets bigger, your concentration will get lower. So this is the slope of the PSD like this line. And when steeper the slope, the greater proportion of the small particles, because the small particle will get more high concentrations. And the flatter the slope, the greater proportion of large particles. So the slope of PSD means the particle size distribute in the environment. And for natural waters, PSD slope generally vary from 3 to 5. So optical properties of the ocean are traditionally considered to be determined by the effect of dissolved organic material. And this word means the small particle generally decide the color of ocean. So how about the large particle? There are large particles, the less abundant particles such as millimeter-sized particles like fish egg. They also be present in high concentration near the surface. So in another word, the large particle will also influence the color of the ocean. So next we're talking about the IOP measurements and the remote sensor. So in situ IOP measurements. In situ means really in the field, in the seawater, not by the remote control. So the word IOP means the principles of light, like the absorption coefficient and measurements. And it appears that the remote sensor like satellite could have been influenced by the large particle, while the IOP measurement may not have been sensitive to this class of particle, like millimeter size of particle. So here's a picture of instrument cage. You can put the measurements in the cage and collect the data. So when we enlarge the red square here, you can even see the particles with your naked eyes. So the large particles do influence the water color. So next we talk about the method, the IOP measurement we use to collect the data. So the first is this one, this hydrogen for particle concentration, like this. And the wet lab BB9 for the scattering and backscattering. And the satellite picture for the RGB images. And the AC9 or ACS for the spectral absorption, the light absorption. So to our first aim, do large particles influence optical properties? So we examine the effect of varying particle size and the refractive index. We use it Ni. So this is reflection. And for scattering, backscattering, and absorption, you may think what is the refracting index Ni. So we focus on the absorption to see how large particle influence the color. So here is the figure. The x-axis for this means the Q value of absorption, which can be simply considered as the absorption efficiency. So it's the ability how the particle can absorb the light. So the Ni, the refractive index we talk about less light, it means when lightly colored, and it has lower Ni. And you see the black light, the Ni is 0, means the light does not be absorbed. It's all refractive. And we know the different Ni will have different Q values. So when the size of particle gets larger, the ability of a particle to absorb light will get larger. And besides to the black light that reflects over light, all the colors will get larger with the size get larger. So do large particle influence optical properties? It appears that the large particle can be highly efficient absorber. And the value varies with the size distribution here and the refractive index Ni. So the second question is, why do we mix large particle with optical sensors? This is the measurement we talked about in the measure. Has an effective sample value up to the 4 milliliter. The sample values are too limited to correct capture the effect of millimeter-sized particles is relatively low in situ concentration. And next we talk about the Dmax. For each combination of size distribution and sensor, there is a maximum particle size called the Dmax. The Dmax is the large particle size that the sensor is able to sample property for particle size distribution. You may think, what is the Dmax? So, you can see this picture, the AC9 talk about in the measure. The y-axis is the particle in the AC9 value sample, and the x-axis is the size of the particle. So you can see the K is the concentration of particle, and the slope of PSD. We talked about in the introduction. So when the concentration gets lower and reach this line. This line means there is only at least one particle in the value sample. So this one particle size we call the Dmax. So see this picture, the y-axis is the size of particle and the x-axis is the concentration. You can see even though in different slope of PSD, the lower concentrations will return lower value of Dmax. So the lower concentration will return lower value of Dmax, like this. And the lower value of Dmax will return restriction of sensor. And why do we mix large particle with optical sensors? So the IoT measurements are biased towards the small particles. So the large particle cannot be truly captured by the sensor because of the restriction of the sensor. So to our conclusion, we have assumed the PSD of particle with refractive index Ni distributions, and we have clearly identified the physical bias basis through which large color particle can affect IOP. And we have demonstrated the standard in situ sampling approach are biased towards smaller or abundant particles. So, thank you.
I think he explained the slope of PSD very clearly, and but I think sometimes he speaks too loudly, makes it sometimes hardly to concentrate.
He explains more clearly than talk one, and he adds some figure to support his content, and let's make it more understandable.
I think you use the more, you make your figure more larger and very easy to read, but your talk speed still a little fast. And you also explain the difficult term very well. But when you talk about PSD in result, maybe the audience already forgot the meaning. So you can talk it more one time.